So in this video, we are going to see how to perform hypothesis testing using t-tests in Microsoft Excel. So as we can remember, there are two types of t-tests depending on how many samples you are working with. Okay, let's start with the one sample t-test. So here we have a sample of the ages of, say, the employees or maybe the faculty of Xavier University as of the present. Okay, there are, I think, 18 of them here. Okay, so for example, you had a survey and you got these answers from these 18 faculty members. And then you have a preconceived notion in your mind that, oh, I think the average age of all of the faculty members in Xavier University is 20 years old. And then you tried to compute from your sample what the average age is from your sample. And you got something that's higher than what you are predicting, 23.5 years old. So, what hypotheses can you formulate from these? Of course, we start with your null hypothesis. And you might say that the average age of the teachers or the faculty in Xavier University using my sample is actually equal to that of 20 years old. That's this, your H sub 0. But then, it is logical for your alternative hypothesis to say that the average age of teachers from Xavier University is a lot older or greater than what I predicted it to be, which is 20 years old. Okay, so these are our hypotheses. Now, Microsoft Excel doesn't support one sample t-test. It jumps right away to two sample t-tests. So we are going to sort of hoodwink it by adding a variable next to the ages column. We can call this the dummy column, wherein the values that we'll input will all be 0. So it's as if there is nothing because all the values are 0, but we have to put it there so that Excel can at least compare our data with something. Okay, so we call that the dummy column. Now, the next step is to go to Data, the Data tab, and select Data Analysis. You will not see this option if you did not enable it in the additional add-ons for Excel. So if you didn't enable the additional add-ons yet, you need to go to File and then enable Additional Add-ons Analysis Toolpack. Now, once you have enabled that, you will be able to see data analysis inside the data tab. You click on that and this drop-down menu, okay, will be shown. Now, in order to perform this one sample t-test, we will choose this t-test 2 sample assuming unequal variances. Okay, so once you've double-clicked on that, this window will appear. Okay, so you click on variable number 1, a cursor will appear, and highlight this first column, ages. By the way, excluding the mean. Okay, we won't exclude the mean. So highlight the first column, ages. Okay, so once that's highlighted, you may then click on the second box here, and then a cursor appears, and highlight everything in dummy, including the title. Okay, so because we are highlighting the titles, we can check this portion. Okay, we'll put a check mark for the labels, and then we'll set our significance level or alpha at 5%. And then choose an output range. maybe on the same data sheet as where your data are located, maybe just beside this, okay? And once you've chosen an output range, you may then click OK. After clicking OK, Excel will be showing this output, okay? So there is something here that we don't need. We don't need this column, the dummy column. So you can simply manually delete that particular column. Okay, and we are shown here with the descriptive statistics, mean, variance, number of observations, our hypothesized mean, which is 20, okay, and then our degree of freedom, which is 18 minus 1. So take note, our hypothesized mean is 20 because that's what we hypothesized the ages of the faculty members in Xavier University, okay, for our null hypothesis. So these were our hypotheses. First, that there was no significant difference, or that it was indeed equal to 20 years old, the average age of the faculty members in Xavier University. Our alternative hypothesis is that the faculty members in Xavier University have a significantly older average age than 20 years old. So here's our T statistic. It's 2.58. And here's our critical value for the one tail. Okay, so we are going to focus here on top for the one tail tests. Okay, why one tail or one-tailed? Because in our alternative hypothesis, there is a one direction, okay, that we are hypothesizing, and that's the greater than direction. So naturally, if we graph our T statistic and our critical value, we are going to get this. Obviously, our T statistic is within the rejection region, which is highlighted in yellow. Okay? This white portion here is the acceptance region. So this highlighted portion is actually what alpha is, which is 5%. But then Excel doesn't end there. Excel also gives us our p-value. So this is our p-value, which is 0.0097 or 0.0098. Okay? If you are going to use a formula in Excel, okay, t dot inverse, and then input there 1 minus the p-value with a degree of freedom of 17, you are going to get our T statistic back, which is this one. Okay, so what does that mean? That means that from our T statistic here, going to the right, this whole thing is our p-value, and that's equal to 0.009797. Okay, or 0.9797%. Okay, so what will be our decision here? First, we reject the null hypothesis that the average age of the faculty members in Xavier University is 20 years old. Okay, why do we reject? Because our T statistic, which is 2.58, is within the rejection region. Okay, bounded by our 1.73 here. Okay, that's our first decision. Or that's the first part of our decision. The second part of our decision is to look at the p-value. So is our decision to reject significant statistically? Well, 0.009 is actually lesser than 0.01, okay, but greater than 0.001. So the result here is highly significant. So therefore, our final decision will be to say that we reject the null hypothesis, that the ages or the average age of the faculties in Xavier University is significantly higher than 20 years old. And not just significantly higher, highly significant. Meaning to say, we can really trust our decision here. Okay, so next will be the two-sample t-test. So here we are going to be getting samples from two populations. So in this case, perhaps the male and female students in a particular class and then their midterm grades for that class. Okay, so, and then we get the means. Okay, so here are the sample means. For the males, the average grade is 2, and for the females, that's 2.03. So what can be our hypothesis? Okay, for our null hypothesis, we may say that the average grade of the males for their midterm is not significantly different or equal even to the average grade of the females. But then for our alternative hypothesis, we have the reason to say that the average grade of the males is lesser than the average grade of the females, as evidenced by our sample means here. Now, after deciding on your hypothesis, you may then go to data and then to data analysis, and then choose this time t-test to sample assuming equal variances. So we are assuming that the variances of these two groups are equal, or their spreads are more or less equal. Okay, so click the first variable here, variable range, until a cursor appears, and then highlight the first column, males, excluding the mean, and then click for the cursor here in variable 2, and then highlight females, again excluding the sample mean. Okay, and then this time your hypothesized mean difference, in the first example that was 20, but now we are hypothesizing from our null hypothesis that there is no difference, so 0. Okay, in the previous example, which I think I failed to explain, that was 20, because the difference between our real data and the dummy was 20, but here we are hypothesizing they are the same, so 0. And then check here labels, because we're including the labels, and then our alpha is set to 5%. Okay, and then select an output range, preferably within the same data sheet as your data. And then Excel will give us this result. Okay, now you don't have to delete the second column because it's needed. Okay, it's needed in this particular test. Okay, so these are our hypotheses. So naturally, because we have a less than operation here, this is a one-tailed test. Okay, so we are going to focus on our one-tailed results here. Okay, so the t-statistics is negative 0.14, and our critical value for a one-tailed test is 1.701. So can we make a graph showing the locations of the t-stat and the alpha, or the critical region, and the p-value? Okay, so since you are unable to draw perhaps right now, as you listen to this lecture, let me draw how this might look like. Okay, so we have our t-distribution. Our t-statistics is at negative 0.14. So that's somewhere here. This is negative 0.14. Okay, let me just cut it to 2 decimal places. Okay, so that's our T-stat. And then our T-critical is at 1.7. Now, we might draw it somewhere here, 1.7. Okay, which is correct because this says 1.7. But take note, in our one-tailed test, we are using the operation less than. So, we use the mirror image of that particular line there. Okay, instead of drawing it there, the 1.7, we'll have a negative 1.7 somewhere here. Okay, and then we can shade everything to the left. Okay, since this is a less than one-tailed test. Okay, so based on this, what will be our decision? Our T statistic is outside the rejection region here, the one shaded in red. So therefore, we say we can accept our null hypothesis. Good news for the males. There is no significant difference between their average grade for the midterm and those of the females. Okay. However, let's look at our p-value. Our p-value says 0.44 or 44%. That's a very, very big p-value. And why is it 44%? That's because if we draw a line here in our t-stat and then shade everything to the left of that, that is our p-value. And that's the 44% that we see here. Okay? So, because that's a very, very big p-value, our result here, although we accept that there is no difference, we also say that the results are not statistically significant. Meaning to say, although we have a decision, our data is not enough to give us a significant result statistically.